5 minutes. Okay. All right. So we're going to talk about separation of mixtures. Now let's first define a mixture. What's the difference, let's say, between a compound and a mixture? What's the difference between element and a compound and a mixture? So
a compound is bonded together, a mixture is just...
All right, so let's start there. Compound is chemically bound together, right? There's a chemical reaction that happens, bonds form, bonds break, and we have a substance that wasn't there before, okay?
A mixture is connected to intermolecular forces.
Right, a mixture is just things mixed together. Is there a chemical reaction there?
No chemical reaction. It's just poles and like magnetic fields.
Right, it's all about if it's polar and non-polar, they'll dissolve. So if I mix, let's say, sand, water, salt, and iron filings, how would we separate them together? So let's say we have a mixture where we have sand, salt, iron filings, which is just shaved iron, little pieces of iron, and salt.
And water.
Okay, so we're going to have to add water to do what? Before we add water, what should we do? Before we do that. So think about it again. You have sand, salt, iron together.
Well, they're not going to mix. They're going to dissolve in water.
Hold on. Oh, you're getting ahead of it. Let's stick to the starting point is iron, sand, salt.
No.
A mix.
Magnet.
Right. So first we're going to use a magnet and do what?
Separate the iron.
Separate the iron. Right? The iron is going to be moved out. Now what do I have left?
Oh.
Salt and sand.
All right.
Now what do I do?
We already had them in separate tubs.
No. What do we do?
Add water to the salt.
Right, so we add water. We know salt is going to dissolve. What's going to happen to the sand?
It's going to sink to the bottom.
It's going to sink to the bottom. Now, how am I going to separate the sand from the salt water? Filter. Okay. Now I have salt water. Remember what I showed you yesterday? That apparatus with the round bottom flask. So now what do I do? Right. What is that called? What is that called? It starts with a D. Distillation. All right. So distillation is separation based on differences in boiling point. Okay. Now, there are a few methods. Maybe this, actually this you have done in AP Bio with plant pigments. No? What?
I didn't
Okay.
Is fancy.
All right. Chromatography is it looks like filter paper. It's a very thin piece of paper, and that you can separate ink and dye on. But also chromatography can be a chromatography column where it separates based on the intermolecular forces. So the column might be polar. It'll take up everything polar, and then everything that's non-polar can go through, something like that. It also it can separate it based on like charge and size and so on. So chromatography is just a way of separating, and it's separation based on the forces of the mobile and the stationary phases. The stationary phase is what's in the chromatography column, what's on the paper, and the mobile phase is the one that's passing through. So we're going to look at this. Oh, no. All right. So the solution or the mobile phase will have certain amount of intermolecular attraction to the surface components of the paper column. Why? Because, well, it's going to have, this is all based on intermolecular force, right? So you have the solution, which we call the mobile phase because it's moving, right? And then you have the paper column, which is the chromatography part. The more polar a component of the solution is, the less interaction it will have with the polar stationary phase, with the moderately polar. So there's a difference in polarity between the paper and the solution, okay? And I'll show you this so you know what in the world I'm talking about. Okay, so let's look at this. Here's a way of separating ink. Why are we separating the colors of ink? Because, well, black ink is made up of different colors, right? It's not, black is not a color, right? It's a mix of the colors. So here's your filter paper, or you can also call it chromatography paper. And you put the ink on that paper, and then you put the paper into a solvent. What the solvent is going to do, it's going to travel up through capillary action. It's going to travel up on the paper. As it travels up on the paper, it's going to separate the different colors of ink based on their interaction with the solvent, interaction with the paper. All that's based on intermolecular force. Okay? So individual pigments travel different distances up the filter paper, and you'll actually see the different colors, and you wait until the solvent is almost at the end, and then you take the paper out. You don't want it to run off the paper. Yeah. Yes. So think about if it's moving faster and higher up, that means it's dissolved in the solvent better. Right? We're going to look at that now. Okay, let's look at an example so we know what we're talking about. Here is a chromatography paper, and this is an actual FRQ question that was given on the AP test. It was there was one that, this is a multiple choice one, but I think this was also based on an FRQ. Yeah. So it says, in a paper chromatography experiment, a sample of pigment is separated into two components, X and Y. Whatever X and Y is, it doesn't really matter for our purposes right now. What matters is where they are on the paper. The surface of the paper is moderately polar. Right? It's not very polar, just a little bit. What can you conclude about X and Y based on the experiment? Now, you see the solvent. What's the solvent? What do you see about? It's a hydrocarbon, so what do we know about hexane? It's really not polar. Okay, so now what can I conclude about component X versus Y in terms of size, polarity, and so on? So let's say this is a look. Here are some multiple choice options to what you're thinking. X has a large molar mass than Y. Y has a larger molar mass. X is more polar than Y. Y is more polar than X. So think about an answer, but I also want to hear a justification to the answer. So think about it. What? These are the AP videos. The GChat also has all the notes for the unit 3. It has the notes and the presentation. It has both packages. Right. This is why I want you to justify. So you say you pick D. You take it back. What is your thought? Okay, what's your thought? Okay. 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 So they travel further. So Y is more polar than X. Why? Hexane is non-polar. Hexane is the one that's picking up the component and separating it. So like dissolves like, correct? As hexane is moving up, the one that's less polar, that is like hexane, is moving with hexane faster. That's why it's all the way up here, whereas Y is here. Y is more polar, it's moving slower because first it doesn't like hexane, and the paper is moderately polar. Okay? Make sense? Yeah. The in some chromatography cases, yes. All right. So I want you to do this one, and I want you to actually sketch it. A student obtains a sample of purple food dye, which is known to contain red and blue dyes, dissolved in solution of isopropyl alcohol. Sketch an appropriate lab setup to use in order for the student to separate the two dyes. If the blue dye is less polar than the red dye, which would expect to travel the farthest on the non-polar stationary phase? I want it to speak. Yes, I want you to sketch where the blue and just sketch that you saw a minute ago on a chromatography paper. I want that same sketch. You tell me. That's the part you gotta tell me. What is isopropyl? An alcohol has an OH group. Isopropyl alcohol is rubbing alcohol. It's a hydrocarbon with a hydroxide with an OH group. I'm not going to tell you that. You tell me. Well, I don't know anything. We've already established this. I don't know. You tell me. By the way, the grace period is 5 minutes. So those of you who come in 10 minutes, just because you're not going to lose the 5%, doesn't mean you're not going to lose the other 5%. You're right. Yes. I agree. You're right. You're right. Alec was 5 minutes early. Amanda wants that too. No, you were here first. Okay.
I was
All right, what happened to my drawing? All right, where's my sketch? Where's the sketch? Sketch it. Come on. You raise your hand. That's it. Now you gotta sketch it. Doesn't matter if you're right or wrong. What's important is that you can sketch it. It's okay to be wrong. I just need a sketch. So I can also tell you if your thought process is okay. Tell me why the blue is has traveled less than red. Okay. Okay. So that's why the blue is moving forward. All right. Any other thoughts on that? How does your sketch look? Who else has a sketch? Is that the same or is it different? Do you have a different sketch? Okay, what are you gonna fix? Come fix it. Okay, come fix what you think you need.